just start recording. So, once you connect your reporting tools like Tableau or things like that with Hadoop cluster, you can easily visualize the data on these tools, and that helps you to look into the data, do analytics on the data, and things like that. That is not really an analytics, but that is a step towards analytics. And same way you can integrate, as I was talking, technologies like R or things like that to do other analytics on the data. And at the end of the session, I'll be giving you a project with some real-time data and giving you some real-time problems, which I'll ask you to do, and then we'll be discussing that in the class, so that you get a real feel about which technology to choose in which area or under which circumstances, and you also able to think how to stitch all these technologies together and how to use them in your real life also. Sounds good? Just quick yes or no on the chat window will help me. Abhya says sure. Akash also says yes. Kamanji say so far so good. Okay, Rohit also says yes. Okay, so I'll assume a yes from Girish also. Sure. So before going ahead, let me just talk about ourselves. So we are into e-learning, and we are teaching a lot of professionals across the world. We are one of the fastest growing company on online training. So I can't comment that we are the fastest, but we are one of them. Then we are teaching students across different things, cutting edge technologies, and we keep on adding courses to our training portfolio. Most of our trainers are working in this industry, and this helps us or helps them to connect with people to the real life examples or real examples or real issues which they are facing in their projects or which they have faced in their projects. So that helps our students to get a real feel of what is happening in the industry. Yeah, that's all. So this is our motto: learn anything from anywhere. So let's move into the big data world. So I hope you remember the days around 1970s, 1960s, 1980s when there was a computer operator who was sitting in front of the PC, entering some data on his desktop. And at that time, desktop was also pretty big. You can't even run a computer without ACs and things like that. So and the data which was generated or data which was generated by these operators were very less, and we were really easily able to maintain them. I hope you also remember the days when we used to have a floppy disk of 3 MB, and then that was increased to I think 5 MB or something, and we were pretty happy that, oh wow, we can store 2 more MBs, and that was pretty sufficient for us to carry the data. But days are gone. We have hard disk or external hard disk of 1 terabyte, and those are not sufficient for me. So the rate at which data which is generated by users, basically there was a tremendous increase in data generation from users who are using the system and that this is only the one thing which is generating data. So there are things like Facebook, Twitter, LinkedIn coming in where users started entering their data which is going into the systems, and there was an enormous amount of increase in the rate at which data was generated. And to process this data, to look into this data, our traditional systems are not capable of these things. Then it's not only the user generated data, the next bigger problem is machine generated data. Can anyone think of why I've placed this picture over here? The previous picture was pretty obvious, and I did not ask why I placed this picture, but why I placed this picture. Any guesses? Akash says weather forecasting. Yes, Akash, weather forecasting. But why I placed this is I'm talking about the machine-generated data, and Grish says cloud data. Grish, no, I'm not coming to the cloud part right now. We'll be looking to the cloud. So, but this is not related to cloud. This is weather only. So, so basically, the satellites which are sending the data for weather forecast are sending enormous amount of data each minute. And when I have to do weather forecast, what would be the weather in London at 2 p.m. I have to process not only today's data, which is sent by satellites. I might have to process last 10 years of the data to predict what would be the temperature at 2 p.m. today. So there's an enormous amount of machine-generated data which we have to process to find out or do to basically research into the data. Abhijat says data around a year. Yeah, might be data around a year also. Any ideas why I have placed this picture over here? Okay, no answers. Okay, so basically, this is again one more example of machine-generated data. A normal Boeing flight with say 30 minutes flight. If 30 minutes flight, Boeing 357 would generate 10 GB of data per engine. A normal flight I think has 4 engines, so a 30 minutes flight would generate 40 GB of data in just 30 minutes. And say if we find a black box of recently lost Malaysian airline flights or AirAsia flights, and if we get their black boxes, just to find out what would have happened to them, we have to process terabytes of data. And if I put that terabyte of data in Oracle Word, it will take me days to just understand the data. Then there's an enormous amount of data on which the medical industry is setting up with or generating from their machines, their user histories, their user treatments and things like that. And that data is used not only to do research in medical field, but to do analytics on the data and predict your future diseases, suggest you medicines and things like that. So I hope you can understand why I placed this picture over here. Transactional data, Abhijat said transactional data. Yes, Abhijat, that is transactional data. Rohit said consumer habits. Yeah, yes, definitely we can relate with that. So if I talk about, say, Walmart is handling more than 1 million transactions per hour. They have 9,000 stores worldwide. Each store has 10,000 to 100,000 SKUs. By SKU, I mean to say number of products available in their systems or available in their stores. So let me give you a pretty interesting example before I go ahead. When I used to buy a vegetable from one of the vegetable vendors who used to pass nearby my house, and I used to buy vegetables with him daily, but some sudden day he stopped passing. I also did not remember I used to buy it from a nearby another vegetable vendor. I recently shifted to New Society around 4 or 5 months back, and when I went down to buy the vegetable, I found the same vegetable vendor sitting nearby. I asked him, hey man, you used to visit that area, why you are not visiting that area and you moved on to this area? He gave me a pretty smart answer. He said, sir, in this area people used to have bigger cars, Mercs and Audis. They have high spending power. Houses in this area are big. So people do not bargain much with me. People are buying more vegetables as compared to that area. people are even ready to buy costlier vegetables. So that guy was intelligent. He was able to predict the market. He was able to do analytics over the market. But as this area or market area was very less as compared to Walmart, his number of SKUs was very less. So he was able to do analytics. He was able to predict his market area where he can increase the sales, and he changed his market area. But if Walmart has to do same thing, on 1 million transactions every hour on their 9,000 stores, think of what kind of data processing they have to do. And so basically the data which is lying in the traditional data warehouse systems has enormous amount of power, and they can mint lot of amount of money on that, but they are not able to process the data in their traditional databases, and that's the reason they are moving on the data to the Hadoop and related world to do the processing on this enormous amount of data. Sounds good till now? Okay, let's assume that's sounding good to everyone. So let's talk about 3 V's of big data. What are 3 big V's of big data? First is called volume of the data. Second is velocity of the data. Third is variety of the data. Let's see what is volume of the data. So if you look, Girish says, yeah. So let's look into what is the volume of the data on which we are setting up with, or companies are setting up with. If we look at, so these figures might be little older, might not be the exact figures, but I'm just trying to give you a glimpse of how much data we are setting up with and what is there in this data. The whole World Wide Web is more than 3 zettabytes of data. The Library of Congress is setting up with more than 300 terabytes of data in their library. Facebook is setting up with more than 30 petabytes of data. This figure is very old. They're now setting up with, I think, zettabytes or something like that. Walmart, I'm just talking about their data warehouse. I'm not talking about their real transactional database system. Just their data warehouse, they are setting up with 2.5 petabytes of data in their data warehouse. eBay is setting up with 10 plus petabytes of data in their data warehouse. So this is the kind of data people are setting up with, and if I have to run some query on a table which is having 10 GBs of data or 1 petabyte of data in Oracle Word or MySQL Word, I am definitely sure you know this is what happens. So the next problem in this area is not the volume of the data, it's the velocity at which this data is growing. So YouTube has new videos of 48 hours each minute uploaded to its website. So if YouTube have to process these videos and figure out whether the content of this video is as per the guidelines or terms and conditions of YouTube, they have to process 48 hours of videos in less than a minute. Okay, you can think of the kind of processing which is required at the back end to process all these videos. Every minute there are 571 new websites launched in this world. Facebook is generating more than 500 terabytes of data each day. Twitter is generating more than 175 million tweets each day, and they process these tweets to find out the hottest topics on top left hand side corner. So at the back end, it's all the processing which is happening on the big data systems. Walmart is generating 1 plus million transactions each hour. This is not only the problem, the velocity of data at which this data is growing. The next major problem is the acceleration of this velocity. That is the rate at which this velocity itself is growing. If I compare the change in the rate at which that data is growing to 2009 to 2020, that would be 44 times. The data production will be 44 times greater in 2020 than it was in 2009. So it's not only this velocity, it's the acceleration of this velocity which is again a major challenge in this world. Then the third major challenge is the variety of the data. So it's in our databases or things like that, we store structured data, and that is pretty easy to process. but the user-generated data, machine-generated data might be semi-structured or totally unstructured, and you have to process that data too. So, so another complexity is the kind of data, which is the variety. That is a variety of data. It could be semi-structured, it could be unstructured, and we have to process that. So, so the processing of this data is complex and require more, is basically more CPU intensive, and here we require high processing power to process this kind of data. Anything till now before I move on to next slide? Okay, assume yes from everyone. Okay, so I think Girish also, not Girish, I think Akash asked me how, or Akash, or I think probably Akash asked me how companies are using big data, how companies are working on this. So this slide is dedicated to that. These are few of the major areas of places where companies are using big data and trying to mint on the data on which they are sitting up with. So for example, predict exactly what customer wants before they ask for it. You log into LinkedIn, on the right hand side, LinkedIn will suggest friends for you. So they predict what you are looking for before you have even searched for a friend. Search for any product on the marketing campaign. Search for any product on the on Amazon website. Go to any other temp website in the world. Somewhere on the left or right or bottom of that website, you will see an advertisement popping up for the same product. At the back end, there is an enormous amount of data processing which happens to predict what you are looking for, analyzing your history, analyzing your click stream patterns and things like that, to predict or to do these marketing campaigns. Then it's not only the case, companies are doing personalized campaigns. For example, Luxottica, one of the premium brands, they are trying to understand their user data, their customer behavior, their past behavior, their geological, their demographics and things like that. And based on that, they are doing personalized campaigns for their customers. So companies are trying to process the data which they have as much as possible and trying to predict or trying to understand how they can increase their sales, how they can increase their customer lifespan, how they can make the customers loyal to them. Fraud detection, pretty interesting thing and highly used. So I'll just give you an example of what is happening in this in the banking industry. The data which is generated in the banking industry is pretty huge. I give you an example. I think around 4 or 5 years down the line, I was working on the data for one of the renowned banks in Singapore. I will not name the bank. I was doing the sum of the transactions for a week in that bank. And one of the guy from the testing team also did the sum of the transactions for 1 week from the same bank, and we found $500,000 difference, $500,000 Singapore dollars difference in our sum. After a discussion or after a fight of 30 minutes, I figured out that I was doing rounding up to 4 decimal places up, and he was doing rounding up to 2 decimal places, and just by difference of 2 decimal places to 4 decimal places, there was a difference of $500,000 transactions. So this is the kind of data which is generated in banking industry, and when they have to do processing on this data, when they have to detect frauds on that data, you can think of what kind of CPU intensive and memory intensive those processes would be. So there are things like anti-money laundering mentors, if you heard for, and there are a lot of other anti-money laundering tools which require high enormous amount of data to look into and generate SAR reports. So each month, each quarter, banks have to generate these SAR reports and submit to the respective governments. Otherwise, they are fined heavily. Citibank, has been fined heavily twice, I think, in the history, because they were not able to predict some of the frauds in their system. So banks have to detect the frauds, and by fraud I mean to say they have to predict some fishy natures in your transactions, in your history, in not only in your transactions, in how you are dealing with equities, how you are dealing with derivatives, and things like that also. So say for each month a salary of $8,000 is credited to my account, but one sudden day 1 million is credited to my account. They are there in my account for 24 hours, and after that they just gone away. So bank will see something fishy over here and will generate an alert. So these kind of alerts are then sent to the government as reports, and these are used to predict frauds in the system. Getting customer excited about their own data. So let me give you another example. There are companies like MyFitnessPal. What they do is they sell consumable products, and based on what you buy from them, they predict what is your calorie intake from those products and display those figures to you on their website or on their apps. So just by processing the data which they have and showing them to the customer, they are exciting the data to the customer. So when customer sees he has consumed so and so calories, and they also give him suggestions like you're consuming more calories or you're consuming less proteins and things like that. So they are basically trying to excite the customer about their own data, and this way customer is becoming loyal to them, because next time customer thinks, oh, I can buy directly from them, and that will give me the diet it takes and things like that. Is it making sense till now, or I'm just speaking to? Guys, you can just ping me yes or no. Is it making sense till now, or I'm just speaking? Rohit says yes. Kamaljeet says yes. Garish, okay, that was an old one. Avijat says indeed it is. Okay, cool, sure. Identifying the customer pain points and solve them. These also says yes from my side too. Okay, cool. That's great. So identifying the customer pain points and solve them. Let me give you another interesting example. I hope everyone of you would have traveled international, and you would have had a hopping flight. So the major challenge in hopping flight is your baggage getting lost, and this is very, very common problem. So although airlines can't change their systems in a day, they can't reduce the human errors, they can't change everything. But what Delta Airline did is they created an app called Track My Bag app. You just snap the sticker which they put on your luggage, snap it and upload it to the Track My Bag app of Delta Airlines. And this app will then track where your bag is lying. So although you might have caught a flight from Singapore to New Jersey, halting at London, and by mistake your baggage has been unloaded at London. But if you are able to track your bag, that your bag is at London and would be arriving to you at so and so time after so and so hours, you will not be calling customer care executives and shouting to them, and you will not be a little bit frustrated about your bag delays and things like that. Although you would be, but that will at least give you give you some sort of satisfaction that yeah, my bag is lying at so and so station, and I'll be getting my bag at so and so time. So companies are trying to use the data which they have as much as possible, and trying to use that data to resolve customer pains and solve them. And then highly used in healthcare and improvement tasks. So by understanding the patient conditions, their lifestyle, their work and home environment, health providers are using. So nowadays in US, definitely insurance companies are looking not only into your work and home environment, not only to your lifestyles, not only to your historical diseases. They are also looking into your driving styles, how rash you are driving, which area you are driving daily, to predict or to give you insurance quotes. The insurance companies are highly using this data of yours to find out what would be the insurance quote which will be given to you. The car insurance companies are getting the data from car vendors to figure out where you are driving, which area you are driving, what is kind of driving you are doing, a rush driving or not, whether you are driving in a crowded area or not, and based on that they are giving you insurance quotes. So social graph analysis highly used in this industry. Big data is highly used, and I think most of the big data related technologies have been evolved because of this industry. So by social graph, I meant to say that the things like Facebook or Twitter or things like that, and how people are commenting on these industries for you. So I just give you an example. I brought a product from one of the biggest e-vendors in India, Flipkart. Somehow that product was faulty. I tried to call their customer care, but they say, sir, we can't help it, and they gave me some excuses. All I did is I placed a comment on their Facebook page stating XYZ. I will not read that comment. So within 15 to 20 minutes, I think, I got a call from Facebook, Flipkart. Sir, please remove that comment from our Facebook page. We'll replace your product in next 24 hours. So at the back end, they are looking into the Facebook comments which are being posted onto Facebook. They are filtering out the comments relevant to them. They are then filtering those comments which are negative. They are processing those comments. Based on the processing of those comments, they are figuring out the customers who have placed those comments. They are based on the customer. They are able to figure out what was the order ID last for this customer, where the customer is facing problem. They figured out my phone number and they called me. So this is how people are intensively using big data and related technologies to process the data, looking at their social graph, sentiment analysis about their companies, about how the company reputation is there in the market. No one wants a single bad comment about themselves on any of the social media. A single bad comment about a company on a social media reduces their customer number extensively. Even a single comment. Research and development, it's not only the companies who are investing highly in the big data and related technologies, it's the government also which have started investing a lot, like Obama administration in around March 2012 announced big budgets, more than $200 billion for big data related technologies in their departments like Department of Defense, National Institute of Health, Department of Energy, US Geological Survey. So it's not only the companies who are spending a lot in this area, it's the government organizations are also using big data and related technologies to do different things, to maintain traffic, to maintain law and order and things like that. Even traffic lights are also automated with the help of high data processing at the back end. Yeah, if they figure out that between 12 to 1 in the night no one travels from this road, they can switch off the lights. The people are trying pretty interesting thing with the help of high data processing power which they have now, and the data which is sitting in their historical databases. All cool till now? Okay. I just assume everything's fine with everyone. So we have already talked about Facebook setting up with this and doing, and that is used for analyzing a pattern.